Hi, everybody. Welcome back to CSCI100, Intro to Computer Science, to the very last video of the course. Now, if you're watching this, you've probably finished all of the previous videos, all 130 of them. You've probably been doing assignments all semester, taking quizzes, labs, homeworks, exams, projects. And now you've made it here. For this very last lecture video, I won't be introducing any new concepts. Instead, I want to take a few minutes to reflect on what we've done in this class and put all the pieces together and lay out what the next steps look like for you, where you can go from here. And to start that, I want to go all the way back to the very first lecture, take a look at the goals for this class. And I wrote them out here when I introduced who I was. My goals were, one, to make sure that you have a strong base of computer science fundamentals. That's crucial. Two, I really wanted to get to know you. And three, I wanted to develop a relationship with you all and be available for you to use me as an industry contact or as a mentor or as a guide. Not just during the course, but also in the future. And breaking these down, let's see if we succeeded. So, building a strong base of computer science fundamentals. You all have learned more than you might realize this semester. We started off learning these core computer ideas that kind of support everything else that we did on top. Understanding the language that computers speak, binary. Understanding how a programming language gets translated, the language that we write gets translated into something that the computer can understand through a compiler. You learn about how to use the terminal. You learn about concepts of memory, why memory is important for problem solving and how computer memory works. About variables and expressions and operators and data types. These most core ideas, primitives, we can call them, that are required for any kind of programmatic thinking. And we talked about what syntax is and what languages are. And then, once you learned all that, we then, frankly, just learned how to program. All of these constructs in Python, conditionals, for loops, while loops, functions, and all these data structures, lists, and dictionaries and tuples, sets, 2D lists. You learned how to work with images and you created image filters in this class and how to take input and output. How to write good tests and check for edge cases, assertions, exceptions, comprehensions, and syntactic sugar. And finally, finishing on classes, which you just learned in the last couple lectures. But all along the way, we've also sprinkled in and been thinking about meta ideas. You might remember from the first or second lecture where I talked about concepts, the difference between like a concept and like a new word. Now, in this class, it's unique because some things that you learned, like variable assignments or variables, you probably were already familiar with the concept from taking an algebra class, but you were learning new syntax, a new way to describe that in Python. Whereas other things, probably like functions, or like range or for loops, these were new ideas. These were new concepts, and you were learning new syntax. And so all along the way, you've been learning aspects of computational thinking. And some really big ones that'll keep coming up, like abstraction, or how you break large problems into sub-problems, which is what really often we're doing with functions. And object-oriented programming and efficiency. And finally, we found time in this class to discuss something that's often not touched on, but is super important, the responsibility that comes with the power that you have to build things. We talked about ethics and technology policy. We also talked about just how to build your career, how to prepare for interviews, what paths there are in tech, how to use LinkedIn, and how to use the different engineering tools that you'll see day to day. Now, I'll point out here that this is a lot of stuff. And you got a tasting, and you'll keep developing these further on as you take more computer science classes. But which of these are most important? Certainly they're all important, and I really think you're going to use all of the different things that we learned in this class as you go on to take more computer science classes or go work in industry, whether it's in computer science or some other field, but where you're going to start applying computer science. But I want you to think most and reflect most on the computational thinking side of things. Ideas of abstraction, how you break large problems down into smaller problems. These concepts are things that you can use in your day-to-day life and just in problem solving. These are skills that will help you in many other fields, not just when you're programming. Thinking about algorithms, how you come up with an algorithm. What is an efficient algorithm? How well does an algorithm scale? Like when you need to solve a problem, the way that you approach that problem, how well does it scale? What's the order of growth? And ideas of kind of bundling data and functionality together, object-oriented programming. These are ways of thinking. These are new skills that you have in your toolbox that are applicable to more than just programming. Now, my second goal was to get to know as many of you all as I can. And it's been great. Through office hours, emails, Piazza, I've been reading your assignments, talking to you in class. I've gotten to know a lot of you. I haven't gotten to know all of you, and so I ask you, if we haven't talked yet, please email me or grab time with me using Calendly. You don't have to come with any particular topic or an agenda. We can just talk about how the class went, about what your interests are, what your goals are, but it'd be great for us to talk. And finally, as I listed, I wanted to be a contact for you, or a mentor or a guide, and be there for you as you navigate your time in college. And you all will be going through lots of things. You'll be going through deciding kind of, do you want to work in computer science or not? What area of computer science do you want to work in? What are you passionate about? What should you try? What internship should you do? How do you get an internship? All of these things, or what classes to take. All of these things are things that I'm available to help you with. And now that I've been your instructor for a semester, you can always reach out to me. So my email is here, alex@krenzel.com. My website, you can find information about me there in my email. My LinkedIn, you can add me and message me on there. While we're here, while the course is going on, you can reach out to the course staff, any of our Howard TAs, any of our Google TAs, and just ask to talk. Finding a mentor is very important. And having that skill to find mentorship as you go along in your career will be really valuable. Something that's important to point out here is you don't have to have been the most talkative student or the best student in the class to be able to reach out and find someone as a mentor, find a TA or me as a mentor. If you're unsure of whether you should reach out, you especially should reach out. Because you never know what'll come of it. The last thing is kind of a secret one. I didn't put it in the slides, but underneath all of it, I had the secret goal of hoping to show you what I think and what I see makes computer science beautiful. I know it can feel frustrating at first, and in the beginning, as you're writing for loops and you're running into syntax errors, and you're writing conditionals and you're being given these examples to solve. But I hope that by the end of the semester, you've started to feel that underneath all of that kind of uncertainty as you're learning language, there's this incredible beauty in what you're doing in creative problem solving, in computational thinking. And especially as you start to get comfortable with this language and begin to express yourself and build things, you can really have an impact on the world around you with what you're building. And so I write this here and I'll read it out loud, that with more practice, as you take more computer science classes and code more on your own, those syntax errors and confusion, those fade into the background. And the thing that's left is just beauty, just expression of problem solving. You can read more kind of on beauty and computer science in this article here, and I have some slides linked that I won't read here. with some descriptions of people talking about what they find beautiful in computer science. But I hope that by the end of your kind of CS journey, or early on in your CS journey, before you have a lot of it actually, you find some beauty in computer science. Now let's talk about what's next. You're at the end of the course. For one, the materials for this course are going to stay up forever. So this website that we have, CSCI100, it will always be here for you. You can always come back to the calendar and scroll through and review any slides, review any videos for, if you have interviews that you want to prepare for, or just anything that you've forgotten. You can share it with friends or with family who want to learn how to code. A fun story that my mom actually wanted to learn how to code, and she took a class that I was teaching on programming to learn how to code. I'd help her with the homework. The other thing that you have to do next is decide whether or not to take more CS classes. Of course, I encourage you to take more classes, but I'm biased, and this is what I do for work, and also this is what I love to do, and this is what I find beauty in. That said, I can just vouch for this as a fun field and just a great area to work in. So as you reflect, if you are going to take more computer science classes, some words of advice. For one, bias towards learning concepts over languages. Try to come away from your classes with ideas that are applicable to how you think and learn how to think. And sometimes I advise you to take classes in a wider array of languages, not to learn more languages per se, but because different languages do different things for you. And like taking more languages will make you think differently about what the computer is doing for you. And once you learn C++, you'll see, oh, Python was doing so much stuff for me. The only way you'll find out like what Python does for you automatically is by using a different language that doesn't do that automatically for you. So I encourage you to learn other languages. I also strongly suggest that you take a wider array of classes or of subfields. You try a wider array of subfields within computer science. Make sure to try some sort of systems class, whether that's operating systems or networking. There are theory classes that are very interesting, like algorithms. Machine learning is kind of its own area. And it's worth trying each of them, even if it takes you out of your comfort zone, even if it's a hard class, just so you know whether you like it. You won't know until you try it. And it's nice. Then if you try it and you don't like it, you'll know that that area isn't what interests you. Now, if you're interested at all ever in doing software engineering, or you're interested in security or systems or computer architecture, at some point you should learn a lower level language like C++. That doesn't mean you need to spend your free time becoming an expert, but you do need to be familiar with what those lower level languages do for you. If you know you're only interested in kind of data science or mathematical modeling, it's okay to focus on Python. Python's commonly used, as is R. Make sure that you get good using Python. On the other hand, I know that some people of the 175 people in the class will not go on to take more computer science classes, and that's okay. But I want you to know that the stuff you've learned in this class, you're now armed with this knowledge as you go out into the world. And the problem-solving techniques you've learned in this class will be applicable to problems that you face in the real world. And you might find, especially in the next 5-10 years, computer science might be useful in whatever field whatever you're doing, it might be applicable. And you'll be ready for that. If you ever want to return to computer science and you don't take more classes at Howard, once you graduate, know that there are lots of computer science materials available online. Coursera.org is a site that has lots of self-paced courses. It's actually where I first learned how to program. It was from a course on Coursera. edX is very similar and has lots of free courses. And on YouTube, there's great tutorials. My tip is when you're picking tutorials, make sure you pick one that's less than 2 years old, because sometimes best practices or language constructs change. Languages evolve over time, and you want to make sure you're watching something that doesn't give you any bad practices or things that are just wrong. Uh, with that, all I can really say is thank you. We've gone through a long journey together. There have been ups, there have been downs, there have been difficult times, and there have been really fun times. But as I sat together, like here, putting together these slides, I really, really felt very proud of how far all of you have come. Especially as I was writing out that slide that had all the topics that you guys have covered. All the different things you've seen in class or learned or have practiced on assignments. It wasn't that long ago, it was just 14 weeks ago, that you were first learning how to write hello world and how to take input from a user and create a variable. There's lots more to learn, and that's the best part. It's so exciting. But you now have some knowledge that opens doors to many other classes, exciting careers, and really, really exciting problems. So with that, thank you for a great semester, and good luck on the final.